Hypothesis test procedure. There are several steps for conducting a hypothesis test. These steps can be broken down in different ways. I have the very first step as meet hypothesis test requirements for the parameter being tested. Every parameter will have a different requirement. The three parameters are proportion, mean, and standard deviation. Second step, state the claim. Third step, state the null and alternative hypothesis. The null hypothesis always has equality. You'll notice down here we have H sub 0. That stands for the null hypothesis. And then a colon. Next I have P. P stands for proportion. This is for the population parameter being tested. Next we have the alternative hypothesis, H sub 1. Sometimes this has an A here instead for alternative. Alternative hypothesis, colon, and then the same parameter that's being tested. In the null hypothesis, you will always use equality. The alternative hypothesis will have symbols that are either not equal to, as stated here, less than, or greater than. The alternative hypothesis helps us with other features in the hypothesis test procedure. If I were conducting a hypothesis on the mean, I would write the null hypothesis still as H sub 0, colon, but now I would use a mean equals, and then I would put in my value that connects to the population parameter mean. The alternative hypothesis would be H sub 1, mu for mean, and then we would have one of the three symbols, either not equal to, less than, or greater than. These three symbols depend on the stated claim. If the stated claim has to do with less than, you use the less than symbol. Greater than, of course, would be for the greater than symbol. And not equal to is when we say something is not equal to the population parameter. So let's say I use a less than here. The values that are placed in the blanks that I have drawn are going to be the same values, and they're going to have the values that are associated with the population's mean. The null and alternative hypothesis can also be written for the standard deviation. If we have it for the standard deviation, it would be the null hypothesis, the standard deviation symbol of sigma, equals for the null hypothesis, some value that is coming from the population parameter, and H sub 1 for the alternative hypothesis. So let's come back to the typed null and alternative hypotheses. You're going to notice that I wrote P sub 0. That is to stand for the population parameters proportion. So these are going to be values. Step 4, determine the significance level, and that's going to also be known as alpha. In a problem, they will tell you the significance level. Standard significance levels are 0.05 or 0.01. Step 5, determine the p-value with StatCrunch. A p-value stands for the probability of a particular statistic happening. Step 6, this is where we start drawing conclusions. If the p-value is less than alpha, the significance level, then reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. Now, to come up with an official way of how to state our final conclusions, we have a formal method. And this flowchart is from a prior edition and textbook, but it is very useful. So we start at where it says start, and you ask yourself, does the original claim contain the condition of equality? Usually it's no. So if it's no, you come down and you follow the following questions. Do you reject the null hypothesis? If you do reject it, then you follow the yes, and your statement in a formal way would say, the sample data support the claim that ... This is the only way to actually say that a particular claim can be true. But notice we just say support the claim. We don't actually prove the claim. Now, If we had failed to reject the null hypothesis, then we would come down below and we would say there's not sufficient sample evidence to support the claim that ... Step 8 is not always required in your homework, nor in a formal paper. But at times it is useful to restate the decision using non-technical terms. And the reason for that is that your audience of readers is not always going to know statistical jargon. Most people are not going to know what these 4 boxes in the formal write-up actually mean. Prior to technologies such as StatCrunch, people had to come to the conclusion of either rejecting the null hypothesis or failing to reject the null hypothesis through a different process, and that was through test statistics and critical regions. So steps 5 and 6 that I provided up above can be replaced with these steps down below. Step 5 can be broken down into 2 steps, where you would first ask yourself, how many tails are in the test, and what are the critical values? You know how many tails are in the test based on the alternative hypothesis. If we have a not equal to, what that means, if I were to draw a type of bell curve, is that I'm splitting the significance levels of alpha into a left tail and a right tail, because not equal to means that I'm looking at less than or greater than a particular population parameter. If I have the less than symbol, then when I draw a bell curve, I'm looking at just the region to the left, representing alpha. And if I have a greater than, I have a right-tailed test because I'm looking for the region on the right. Now, the vertical lines that are drawn to separate the particular tails are called critical values. And critical values are different for each population parameter. Remember, the population parameters are population proportion, population mean, and population standard deviation. Each one of those has a different distribution model, and hence they have different critical values. 5B, you determine the test statistic with StatCrunch. Now, there are official formulas that you'll see in your textbook, but it's easier just to find them in StatCrunch. And step 6, the way that you draw your conclusion is if the test statistic falls within the critical region, then you reject the null hypothesis. The critical region is the entire green area. The critical value itself is just the boundary of that area. If your test statistic falls in the green shaded area, then you reject the null hypothesis. If your test statistic happens to fall in the white area, then you fail to reject the null hypothesis.